This is Glencoe Course 2 Math, Lesson 6-5, yes, on what they call more two-step equations. I like to call these multi-step equations for one reason, because we're not going to use the steps that they used. These problems can be solved using two steps, except those two steps are the exact opposite of what we learned on Monday. We don't want to do that. We want to have one list of steps when we see an equation that apply every single time. Sometimes we might have to do more steps, sometimes we might have to do less. However, we want the same list of steps for every type of equation. That's why I call this multi-step. Because with my multi-step, we will be using those same two steps we used before. We're going to add a little extra onto it. So, my first step is going to be to distribute. My second step, just like it was before, is to eliminate addition or subtraction. And my third step is to eliminate multiplication or division. So I'm going to write those over here to the side. I recommend you write it in your book in the work zone section that's green. Now, I have chosen to abbreviate addition and subtraction to add/subtract. And multiplication and division are mult and div. Okay? Those are my abbreviations. We are looking at page 482. So, if I look at example 1, I have 3 times the quantity x plus 5, that equals 45. If my first step is to distribute, that means that I need to distribute my 3 to the quantity x plus 5. That gives me 3x plus 15 equals 45. That's step 1. Now I have an equation that looks a whole lot like what we did before. I have a term with a variable. I have a constant or a number only term. And I have something that equals. Step 2 says to eliminate my addition or subtraction. So then I'm going to subtract 15 from both sides. (3x plus 15 minus 15 is 3x. 45 minus 15 is 30. My last step is to divide both sides by 3. To eliminate the multiplication between 3 and x, that leaves me with x equals 10. After I distributed, my steps were the same as what they were before. That's why we're doing it this way. Does anyone have any questions?
What's so funny?
Did you leave something in the restroom?
Oh.
Do you need to go back and check?
Yep.
Go.
Check what?
It takes both of you to go check.
Yeah, it's small. No homo. No homo. Why would you say that on camera?
Oh,
He lost
Now we have to
I
restart the
adapted
video
like
over again.
And then
All right. Love having other things happen in class on video day. Let's get back to this equation. Were there any questions about the equation?
I did have a question, but I forgot.
Okay. So, then let's look at another one. Because sometimes we don't distribute whole numbers. Sometimes we distribute things like 2/3, like we do in example 3. 2/3 times the quantity x plus 6 equals 10. Yes, we're at a pass. Scoot over a couple inches. Okay. Now, we're going to distribute the 2/3 to the quantity x plus 6. That will give us 2/3 x plus. If I take 2/3 of x, 2/3 of 6 is 4. And that equals 10. There's two different ways. There's two different ways that we can figure out that 2/3 times 6 equals 4. Option 1 says you do it longhand. You take the 2 times 1, you get 2 times 6, you get 12. You get 3 times 1, which is 3, and 12 divided by 3 equals 4. Option 2 says you recognize that 6 is twice of 3, is double 3, so you double 2 to get 4. Either way works. That's step 1.
I ain't do this.
Step 2 says that we're going to subtract 4 from both sides, giving us 2/3 x equals 6. Now we need to divide. Yes. Now we need to divide both sides by 2/3. And we find that x is equal to 9. How did I do that? I know that 6 over 1 divided by 2 over 3 is equal to 6 over 1 times 3 over 2. 6 times 3 is 18. 1 times 2 is 2. And 18 divided by 2 is 9. This part you can do in your calculator. Questions. What questions do we have? No, we know what to do?
No,
No?
Kind of.
not really.
I get it. Like 60,
Like, how did you-
67.
Alright, let's raise a hand so I can answer one question at a time.
I get it, 67%.
Let's raise a hand so that I can answer one question at a time. when we're not feeling real sure of what's going on.
Yes.
Is the issue with the fact that we are not using whole numbers, or is the issue with the process?
Whole numbers.
Both.
It's the-
I mean,
recognize the whole number.
We're not sure of the process?
The third step.
I'm sorry. Yes, today's video day. So, let's go over what our process was.
Yes.
Okay. Step 1 says to distribute. That means we take that number outside of our parentheses and we multiply it by each part inside the parentheses. So we take 3 times the x and 3 times the 5. That gives us 3x and 15 here in example 1. In example 3, that gives us 2/3 of x and 4. Because 2/3 times 6 is 4. Better?
Yes, better.
Okay. Which part? Okay.
I'm lost on the third part.
Okay. So, again, what we did, instead of saying that I have 3 sets of the quantity x plus 5, we rewrote it using the distributive property to say that in total I have 3x plus 15. Okay? Instead of saying I have 2/3 of the quantity x plus 4, what I actually have is 2/3 of x and I have 4. I think I misspoke earlier. Instead of saying I have 2/3 of x plus 6, actually I have 2/3 x and I have 4. Okay? And I get that by multiplying what's outside of my parentheses by everything inside. Okay? Step 2 says that I eliminate any addition or subtraction. By doing that, I remove what we call an outlier. That means that I take the number on the same side as my variable that's not attached to my variable, and I get rid of it mathematically. If it's a positive number, I subtract. If it was a subtraction sign or if it was negative, I would add. Okay? So here I subtract 15. Here I subtract 4. Better? Okay. Third, I eliminate the multiplication. If I have 3x, that means that I have 3 times x. 2/3 x means that I have 2/3 times x. So to eliminate that 2/3, to eliminate that 3, I have to divide by that same amount. Because I don't want to know what 3 x's are, I want to know what 1 x is. I don't want to know what 2/3 x is, I want to know what 1 x is. So I have to get rid of that coefficient. That's called an attachment. Then I get my solution. Who? You can check and see, but please don't answer. Oh, you're not answering. You're not answering. Okay. Questions? You still have questions?
Can you do
What?
an example?
We can do another example, yes. However, I need my students to refocus and end their conversations. All right. another example. Because we're worrying about process,
Oh.
excuse me, we're working with the process. Okay, if we have rational numbers outside of that set of parentheses, our process doesn't change. We might have more fractions or more decimals that we have to work with, but these 3 steps don't change. Okay? So if we look at example 4, we have 0.2 times the quantity C minus 3, and that is equal to negative 10. Okay? So, the first step is to do what? What does my first step say to do? Distribute. What quantity is getting distributed? 0.2. Okay? What is 0.2 times C?
0.6.
0.2 C. Plus, what is 0.2 times negative 3?
So what now?
0.2
Yeah.
times negative 3.
0.6.
Close?
Yeah, negative.
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 Negative 0.6. Okay? That equals negative 10. So we did step 1.
Yes. Yes, we have.
We have done step 1. What does step 2 tell me to do?
Eliminate.
Add, subtract, away.
Eliminate my addition or subtraction. I have the addition of a negative here. How do I get rid of a negative?
Absolute value.
Negative. Take off the dash.
Hold on. If I have a negative quantity to get rid of, what do I have to do?
Make it
Add a positive, add a positive. Okay? So I need to add to both sides a positive 0.6, correct?
Yes, ma'am. Yes, indeed.
Okay? This gives me 0.2C
yes.
equals negative 9.4. Because when I take a negative and I add a positive to it, I actually find the difference or I subtract and keep the sign of my greater absolute value. Okay? Now what do I need to do? What does step 3 tell me to do?
Eliminate that. Multiply. Divide.
So I need to eliminate the multiplication division. So I have multiplied together 0.2C. Those two things are multiplied. You can check to see who it is, but you may not answer. We're going to divide both sides by 0.2C. What's funny?
Those are wrong.
Okay. When I divide both sides by 0.2, C is equal to, we need to do a little bit of long division. We know that our answer is going to be negative because a negative divided by a positive is a negative. 9.4 divided by 0.2, I need to move each decimal point over one place. 2 goes into 9, 2 times 2, nope, that's not correct, I'm sorry. 4 times 2 is 8, I subtract and I get 1. bringing down my 4. 2 goes into 14 7 times. 7 times 2 is 14. Subtract and I get 0. So that means C equals negative 47.
Always make sure you were right.
You good?
This one, you have a spelling. Yeah, both C plus. I got you. Alright.
Okay.
Somebody ain't calling your phone, boy.
Excuse me. Ladies and gentlemen, are there any questions about what we did here?
No, I get it now.
If a calculator was available, could we use a calculator for this part?
Yeah.
Yes.
You already know.
Can you put a variable in your calculator?
No.
No, it will give you the wrong answer.
No, ma'am.
Okay. Are there any questions about the process?
No, ma'am, I get it now. I get
Questions about the process?
it. 99%.
All right. Thank you very much.